At example 3 here, for each function below, we're asked to find the slope of the tangent line using this particular limit definition, and write the equation of the tangent line at the given value and check our answer graphically, so using Desmos. So our first example here, we've got the sine function f of t equals t, or excuse me, f of t equals sine of t at the value a equals 0. So we're going to go ahead and bust out our formula here. The slope of the tangent line is the limit as t goes to a of f of t minus f of a over t minus a. So in this case, our a is 0. So this would be the limit as t goes to 0 of f of t, which is sine of t, minus f of a, which is sine of 0, over t minus a, which is t minus 0. And we know that the sine of 0 is 0. So this is the limit as t goes to 0 of sine of t over t. And that's one of our famous indeterminate trig limits. We know that that limit is 1, thanks to the squeeze theorem. So the tangent line, y equals the slope of the tangent line times x minus a plus f of a. Excuse me, in this case it's a t minus a plus f of a. So it'd be y equals, slope of the tangent line was 1, a was 0, and the function was sine. And once again, the sine of 0 is 0. And so I'm getting from my tangent line, y equals t. So that means if I graph the sine function near 0, and I zoom in, that sine wave should look look closer and closer to the line y equals t. So let's fire up Desmos and check this out. So once again on Desmos, I'm going to just type in, use the variable x. So we'll do f of x is sine of x. And instead of y equals t, we'll do y equals x. And we'll click there at the origin. And sure enough, I think you can even see from this vantage point, as we get closer and closer to the origin there, the graph of the sine function and the graph of that line become indistinguishable. All right, so that's our graphical confirmation that we found ourselves the tangent line. Okay, up next, we have f of t is cosine of t when a is 0. So once again, the formula that we're asked to use to find the slope of the tangent line is the limit as t goes to a of f of t minus f of a over t minus a. So in this particular case, the a is 0. F of t is cosine of t. F of a would be the cosine of 0 over t minus 0. And here remember that the cosine of 0 is 1. So we get this is the limit as t goes to 0 of cosine t minus 1 over t. And this is very close to a classic indeterminate trig limit that we had back in the last chapter. In the last chapter, though, we had 1 minus cosine t over t. That's all right. We can factor out a negative 1. Like so. We know that as t goes to 0, 1 minus the cosine of t over t goes to 0. So using properties of limits, we can say, well, this is going to go to, the opposite of 0, negative 1 times 0, which is 0. That means the slope of our tangent line is 0. So that means we actually have a horizontal line. So tangent line, once again, y equals slope of the tangent line times in this case it's a t again, t minus a plus f of a. So slope of the tangent line is 0. A is 0, so a lot of zeros here. So we just get y equals f of 0, which is the cosine of 0, which again is 1. So this says as I zoom in to the cosine wave, when t is 0, it should flatten out to be just the horizontal line y equals 1. So we'll check that with Desmos here. So we'll change from sine to cosine, and the line from y equals x to y equals 1. So there's the cosine up there. We'll zoom in. There's the horizontal line, y equals 1. And even from this far away, you can see that as the t's get closer and closer to 0, right, this curve flattens out, and it's hard to tell the difference between the curve and the tangent line. So that'll do it for example 3.